Subscribe now and click on the bell icon to never miss learning from Vedantu.
Now let us move on. Okay, people, now in the last class we ended up with the rules of the electronic configuration. Yeah, we had done off-bow rule, Hund's rule of maximum multiplicity, and Pauli's exclusion principle. Yeah. So please give me the electronic configuration of scandium. Fatafat say 1s, 2s, 2p, 3s, 3p, 3d, 4s, so on and so forth. Come on, people, quickly. I want to see at least 4 responses, and then I'll start writing it on the board as well. All you have to do is fill up the 21 electrons in these orbitals based on your n plus L rule. Yeah. Okay, good. So it will be 1s2, 2s2, 2p6, 3s2, 3p6. Okay, कितने भर दिए हमने? 6, 7, 8. जितने भी भर दिए. So now what you will do is what? 3d3. Will you do this? No, exactly. You won't do 3d3 because of the off-bow principle. Okay. What you will do is first fill the 4s. Okay. First you will fill the 4s. So it is 4s1. Sorry. 4s2. Yeah. You will fill the 2 electrons in the 4s. Then when the 4s is fully filled, then you will come back to the 3d to fill the last remaining electron. So this is the electronic configuration. If you write it completely, 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Okay. So people, it is always a good practice to write it like this and not like 4s2, 3d1. Okay. Always keep the orbitals in terms of their increasing n. Okay. So no, this is not wrong. This is also totally fine. Okay. But practically speaking, the fourth shell is always above the third shell. Okay. Its energies might vary. Okay. But technically speaking, the fourth shell has a greater principal quantum number. Therefore, this is a better way to denote it than this. Okay. So this is just a better way to denote it than this. Okay. But anyway, both of those notations are correct. Okay. You will find both of these notations in books as well. Your teachers at school might also have, the way of remembering it like this one. But it is preferred to write it in this manner. Okay. I'll just give you a hint why. Because when you will ionize scandium, okay, if you start ionizing scandium, I know that you filled the last electron in the 3d orbital, but when you are ionizing the scandium, okay, let's say you're taking away electrons. First, you will take away the 4s electrons, then you will take away the 3d electrons. Okay, so whenever you are ionizing, all right, the 4s electrons will leave away first, and then the 3d electrons will leave. Okay, so this is a way to write the electronic configuration. Okay. Now there is another way to write the electronic configuration. I'll show you this in the periodic table itself. Okay. So the noble gas that comes before scandium is argon. Right? Yes, Amrit, you are right, because 4s is the valence shell. Okay. So if you ionize any atom, the valence electrons leave first. So according to the n plus L rule, yes, you have filled the 3d later, but technically speaking, the 4s is still the valence shell, and that is where the ionization happens from. And that is why you should write the electronic configuration in this manner. Anyway, so look at the periodic table. Argon is the noble gas that comes right before scandium. Okay, so you can write the electronic configuration in this manner as well. Okay, argon, and you can write whatever is remaining, that is 3d1, 4s2. Okay, you will have a 3s as well. 3s2. रुक जाओ, क्या कर रहा हूं मैं? Yeah, so you have argon. Okay, you have 18 electrons already over there. So the next 1, 2, and 3 electrons is something that you have to write about. Okay, so what are those 3 electrons? Those are 3d1 and 4s2. Okay, that's it. Got it? So this is another way of writing the electronic configuration in terms of the noble gas. Okay. So this is just a shorter way to write the electronic configuration. Now, let us talk about the electronic configuration of calcium. Okay. Okay, Manasi has already given us the answer. So calcium is 21 less than scandium. So simply, basically, you can write argon and then a 4s2. Okay. Then you have chromium. Now, chromium is interesting as a case. Karan, you are correct. Other people? Anyone? या करण ने सही लिख दिया, तुम भी लिख दो साथ में. Yes. So the electronic configuration for chromium, I'll write down the whole thing just for the sake of it. 2p6, 3s2, 3p6, 3d and 4s. Okay. So the electronic configuration, why isn't it? So I'll write actual over here. Okay, this is the actual configuration that is seen. Okay, but the expected configuration that you would have wanted, the laws that you always follow. Okay, but this is the actual thing that is noticed in nature. All right. Now there is a reason behind it, and that reason, in very layman terms, says that half filled and fully filled orbitals have greater stability. Okay, so in this case you have a 3d4 which is not half filled, not fully filled. You have a 4s2 which is fully filled. Okay, instead in this particular case both of these orbitals are half filled. Okay, the 3d subshell is also half filled and your 4s subshell is also half filled. Okay, it is found out that half filled and fully filled orbitals have greater stability. So in this case, since both of these are half filled, that is why chromium prefers this particular electronic configuration. Okay, now people do understand that this particular statement is a reason that we've given to this particular observation. Okay, this particular statement doesn't give us the observation. The observation gives us the statement. Okay, so please have that in your mind. Okay, so the point is that this is sometimes called an exception. Okay, but the exception exists only in terms of the human understanding of the concepts. Yeah, so according to the theories that we humans could build, yes, this is an exception to those theories. Okay, but this is what exists in nature. Okay, Janathanan, a lot of elements in the D block and F block have such configurations. Okay, now why are these more stable? This happens because of the virtue of symmetry. I would love for you guys to find out the reason on your own. Okay, in the next class, if you want, you can discuss with me as well. Okay, find out the reason on your own why it has greater stability. It has to do with symmetry. Okay, and you can of course read up the NCERT's last page of this chapter, and it is very explained in a very good manner over there. Okay, so try to find out why it has a greater stability. I'm sure most of you already know about it. Okay, it has to do with symmetry. Okay. Ramya, a lot of heavy elements don't follow these three laws as they are. Okay, a lot of heavy elements, especially in the F block, they have very weird configurations. Okay, so again, since those are exceptions, some of you are expected for you to remember. For example, the case of chromium. Okay, and some of those are not necessary for you to remember. चलो ठीक है. So ये हो गया chromium का. Remember the chromium's configuration is 3d5 4s1 and not 3d4 4s2. ठीक है? You can call this an exception, but I hate the word exception, so I will call it an anomaly. Just because I hate the word exception. ठीक है? Bromine. Please tell me. Okay. Awesome. खुशगम ने अभी बता दिया. Sam has also told me. Yes, so it is argon. Then you have all the d electrons fully filled. Then you have the 4s. Again, this will also be fully filled. Then the Fifth electron, basically you will have to fill 5 electrons in the 4p. So it is 4p5. Yeah. So this is the case for bromine. Please write down the electronic configuration for copper, people. Again, yes, it is an anomalous case. Yes, so similar to chromium, copper is also an anomaly. Okay, so you also have 1s2, 2s2, 2p6, 3s2, 3p6, then 3d and 4s may you have a panga. You would expect it to have a configuration of 3d9, 4s2. Okay, but again, what happens is you find out that it is 3d10, 4s1. Okay, so it fully fills its d orbital, its d subshell is fully filled, and you have just one electron in the valence shell, which is the 4s shell, 4s subshell. Okay, people, so this is again an anomaly. Okay, so I will put a green colored star mark over both of these cases so that when you are revising, you always remember these. Okay, so chromium and copper, again, people, please remember that these two are anomalous cases because of this statement that we give, which is because of the virtue of symmetry. Please try to find out what exactly happens in the case of symmetry, and you can read the NCRT for the same. So yet chromium and copper are two examples. Okay, if you look at silver, again, you have a very weird configuration. As you can see, people, in this dabba, you will have the electronic configuration. So if you look at silver, again, in the last, it has one electron. Okay, so in the 5s, it has just one electron. Similarly, for gold, it has one electron in the 5s. Okay, but if you look at chromium, it has one electron in the 4s. Molybdenum also has one electron in the 5s, but tungsten, on the other hand, doesn't show an anomaly. It just goes by the laws that we have. Okay, so well, that is why these are called exceptions. Okay, so people, you can remember it in terms of copper, silver, gold, chromium, and molybdenum. And there are a lot of cases in lanthanides. We'll deal with them when we study about lanthanides in the chapter of lanthanides and actinides. Okay, so just notice there is a 9 and 2 in the last shell. Okay, so ये देखो यहाँ पे if you click orbitals on this particular website ptable.com, it tells you exactly how these orbitals are filled. Okay, and it gives you the electronic configuration over here. So go ahead and explore after the class. Okay, 4s1 3d10, 5s1 4d10, 5s, sorry, it is even more weird in case of gold. You have a 5p6, 6s1, then 4f14 is fully filled, then you have a 5d10. Yeah, in case of lanthanum, look at the weird part. It is a 5d1. Okay, so lanthanum is 5d1 and cerium is 5d1 4f1. Super weird. Okay, so don't worry about these cases right now. Okay, so please don't worry too much about these cases right now. This website is awesome, so I'm going to give it to you in the chat box as well. Okay. Sam, I'm sure all of you guys have the mnemonics to the periodic table that I've made. So if you have those, yes, Tanmay, again, as I told you, the statement that we give stems out of the observation. The statement itself doesn't give us the observation. So that statement is just there to explain those few anomalies, which again breaks apart in the case of lanthanides, which we'll deal with later. Okay, people, so अरे यार WhatsApp group पे after the class I will share the link. ठीक है, so I will share the document itself after the class on the WhatsApp group. So what that document will enable you to do if you remember it completely. Okay. Ramya, please try to Google it later. अभी उसमें नहीं जाएंगे. Okay. So that particular mnemonic, if you remember all of it, you'll be able to write the periodic table on paper in just 2 minutes. Okay, I'll show it to you later. Okay, and those are mnemonics in a very sophisticated manner, although funny, so that you can remember them. Okay, in the next class, perhaps we can take some time to discuss those as well, आराम से. So फटाफट से we can do that. लो helium यहाँ वापस चला गया. Helium here is put over here so that you have space for the electronic configurations to be written over here on the screen. Okay, so it is not in group 2. It is in group 18. All right, it is just the case for the tab of orbitals. So please ना confuse मत हो. Yup, Shruti, it is the Google Doodle. Yeah. चलो वापस चलते हैं. So point is, electronic configurations के लिए the cases that you need to remember are chromium and copper. When you keep on going and when you do a lot of questions, which will come from the chapter of periodic properties, which will come from the chapter of coordination compounds, eventually you will start memorizing these without even having to put any effort. ठीक है, तो चलो ये electronic configurations की बात हो गई, आगे बढ़ते हैं. Okay. Now let us talk about the magnetic moment. Okay. So whenever you write an electronic configuration, in a lot of cases, you have unpaired electrons. Okay. You have unpaired electrons in a lot of cases. Let us take any case in which there are unpaired electrons. Let us take the case of cobalt. Okay. So the cobalt basically has your electronic configuration of this. Okay, so you have 4s2 3d7. Yeah, so for cobalt you have so on and so forth, 4s2 3d7. Okay, or if you want to write it in a better manner, 3d7 4s2 जैसे भी लिखना है आपको. Yeah, now if I draw the 3d subshell, okay, and if I try to fill the electrons in it, okay, so यहाँ पे I will have 1, 2, 3 and 4. ठीक है. So I've made 5 boxes over here. Now how will I fill up these? I will fill up these using the Hund's rule of maximum multiplicity or Hund's rule. So I will fill 1, 2, 3, 4, 5, 6 and 7. ठीक है. So 1, 2 and 3. 3 electrons are unpaired. Okay, these electrons are paired, these electrons are unpaired. Now you have studied in the NCERT that these electrons have some sort of an angular momentum to it. Okay, now there is a term called magnetic moment, okay, which you will study about more in case of the dipole moment. All right, when you study that in physics with your physics teacher. Okay, so magnetic moment is a property that is associated with these unpaired electrons. Okay, and this magnetic moment, hold on. So this magnetic moment is basically equal to, people, do you know the formula? Anyone? किसी को याद है ये formula? किसी को नहीं याद ये formula. Interesting. So I'll tell you. Yes, Rohit, you are correct. Yeah, so खुशगम ने definition भी दे दिया है magnetic moment का. ठीक है. Anyway, you'll study about it in physics. ठीक है. So people, I'll just tell you where to revise this particular thing from. Okay. Again, your notes that you have are very well written. So the theory notes that you will have for atomic structure, right? इसमें बहुत अच्छे से दे रखा है. Okay. So again, just taking this opportunity of taking you through these notes. अरे भाई, why was there a problem? Let me see. Structure of atom कहाँ चला गया यार? This one. So I hope you can see my screen, people. If you can, then brilliant. If you can't, then okay. So this is the formula of the magnetic moment. I just pointed out this particular part in the notes as well, just to make sure that you read the notes after the class as well. Okay, so in पे focus कर लेना. All right, the magnetic moment is basically equal to root of n into n plus 2, where n is equal to the number of unpaired electrons. Okay. Okay, what is magnetic moment? You'll deal with that in physics anyway. Okay, so कर लेना. All right. So this is the formula. रुक जाओ. It is very beautifully given in the notes as well. N into n plus 2 Bohr magnetons. Okay, and this Bm is basically a unit. Okay, it is called Bohr magnetons. Okay, so I'm sure some of you might have encountered some questions like this, that vanadium has a Bohr magneton of 1.73. Yeah. So what would be the electronic configuration, so on and so forth. So this is the formula that is necessary for those questions. Okay. So in this case, can you give me the calculation of magnetic moment? Root of 3 into 5. Okay. The root of 15 will be your answer. Okay. Root of 15 Bohr magnetons. 3.7 something, I believe. Okay. So this will be your answer. Root 15 Bohr magnetons in case of cobalt. So the magnetic moment of cobalt because of the unpaired electrons is equal to root 15 Bohr magnetons. Okay? The 20-25 minutes that we have, we'll try to study a little bit of periodic properties. Now I'm sure that all of you know already about the history of the periodic table, right? You sure know about the Newland's octaves, you know about Mendeleev's theory, you know about the triads that were given by Dobereiner. I'm sure that you know about Lothamier's curves as well. So if any one of you doesn't know these concepts, please write a no in the chat box so that I know where all of you guys are. Chalo, theek hai. So I believe most of you, yes, we will do a quick recap. That is why I asked that should we pump up the pace of this chapter. Yeah. कोई बात नहीं जनार्दनन. It is very easy, just the history, and IIT JEE में उसके related questions नहीं आते हैं. In boards and NCERT you will find a lot of questions according to that as well. But in IIT JEE history से hardly there is any question ever. ठीक है? So this is again from NCERT. Okay. So people, now you have a new chapter from NCERT to study. Okay. And if you don't complete your existing homework, new homework is going to keep piling up, and then you'll drown in burdens of homework, and it is very hard to save you from that. So I have been there, I have done that mistake. Please don't do that, my dear friends. Complete your homework as soon as it comes to you. Okay. So yeah. So don't worry, we all have been through that situation, been there, done that, sabke saath hota hai. But please start reading the NCERT. It is the chapter number 3 from 11th class NCERT. Okay, chemistry, periodic properties and all that jazz. Okay, yes, part 1. कुशगम प्लीज यार वो दोबारा गलती मत करना, मैंने सीख लिया गलती करके. I have learned from that mistake. So please don't repeat that for your own sake. Chalo, okay. Why do we need to classify the elements? Because we have so many elements. Yeah. So right now we have 118 elements, and we have already discovered these 118. More of those are on the way to discovery. Okay. So there are some complications of discovering the 119th and 120th element, but scientists are working on them. So some sooner. Nani ji ke ghar pe tha main. I used to stay at my grandmother's place. Yeah, and I haywire on that particular bed, and I used to sleep in that tiny space that I had, the 20% of the space of the bed. Okay, and again the same was the case with my study table, and I had no specific time of waking up or sleeping. I just had to wake up in time for my coaching classes. Yeah. So उसके लिए मैं उठ जाता था time पे, but apart from that, जब टाइम मिला, जब देखा, सवाल कर लिए. Whenever I'm bored, I used to practice my beatboxing and I used to surf around on YouTube. ठीक है. And then again then my brain was fresh. I used to study again. Then I used to go to the kitchen, make popcorn at 2, 3 in the night. I used to have YY noodles, so on and so forth. Okay? So yes, every one of us will go through these things in nature. In nature, बोल रहा हूँ. So much atomic structure is filled in my mind right now. मैं हर चीज के बाद in nature लगा देता हूँ. यार. Rohit, tell your mother that there is no need to scold you for that. Some people are designed to be able to study better at night. Okay, there are all sorts of human beings. There are the majority who wake up in the morning early. The minority, like us, are nocturnal people who prefer staying up at night. Yeah, कोशकम भाई पढ़ लिया कर. Neeraj, don't worry. We were just having a random chat. रम्या डोंट वरी, उनको बोलना हमारे सर ने बोला कि रात को पढ़ना अच्छा होता है. In IIT, when you go to IIT, everyone will be a night owl. Our canteens are open till 3 a.m. यार, मतलब. अच्छा, चलो, people, yes, that is true. Okay, you can have all sorts of good food till 3 a.m. Every hostel canteen is open. I'm talking about IIT Bombay. So, chalo, ठीक है. So many elements, we need to classify them because there are 2 million inorganic and 18 million organic compounds. Moving on, the first attempt was done by Johann Wolfgang Dobereiner in the early 1800s to classify the elements. He gave us triads, okay? And these triads were basically groups of 3 elements that he chose randomly, and the only thing that was unifying these is basically the middle element. Look at this particular statement over here. People, please focus on the whiteboard. The atomic mass of the middle element is the mean of the atomic mass of the other 2 elements. Okay, so if you have 40 plus 137 by 2, it will be equal to 88. So this is the law of triads. Okay, and this law worked only for a few elements and thus was dismissed as a mere coincidence. Then we had the law of octaves. Octaves, basically every 8th element is similar to the first element. It was given by this gentleman over here called John Alexander Newlands. Okay, and he couldn't explain why this happened. He worked only Okay, cool. We are just revising this. That is why it is super fast. Okay. So, Kushagam, क्या हो गया यार? What is the problem? And it couldn't fill the noble gases. Okay, and it worked only till calcium. Kushagam, we'll talk about that later. Okay. Okay. Anyway, all of this, and then there were a lot of limitations. After calcium, things started breaking apart. I remember Amrit had also asked me a question on the same, that why? Okay, so why? Because now you know electronic configuration. There is a 3D10 that you have to fill after the 2s2 2p6. That is why it just starts breaking apart. Okay. Then you had Mendeleev and Lothar Meyer. This link was also given to you to understand more of Lothar Meyer's work if you wanted to. Okay, both said that elements are a periodic function of their atomic weights. The periodic properties are a periodic function of their atomic weights. Yeah, and we have spent a lot of time on this particular statement as well. This was the Mendeleev's periodic table. ठीक है, anyone please help Ramya get this link on WhatsApp later on. Okay, आप अगर सर्च करोगे ऑनलाइन लोथर मेयर वंडर विज किड्स इट विल कम. तो WhatsApp पे कोई प्लीज पोस्ट कर देना. Okay, so I'm trusting you guys. Okay, Dheeraj will do that. Awesome. You will Google it, Lothar Meyer WizKids, and it will come to you. ठीक है, तो कोई बात नहीं, पूरा टाइप करने मत बैठ जाना, use google.com, ठीक है. Then Mendeleev's periodic table, it helped him predict stuff, which was cool. He predicted Aka aluminium, that is gallium, Aka silicon, that is germanium. We also discussed why this happened, and there were a lot of drawbacks to Mendeleev's periodic table as well. Yeah, position of hydrogen not justified, position of lanthanides and actinides, so on and so forth. Okay, so Kanishk, are you not in the WhatsApp group? ठीक है कनिष्क, अगर तुम नहीं हो व्हाट्सएप ग्रुप पे प्लीज ऐड हो जाना. ओके, या people focus on the recap please. This was your Mendeleev's periodic table. Now then you entered the modern days. Okay, people focus on the modern days. If you don't focus, I'll have to disable the chat box, which is one thing that I hate doing. So cool. Okay, so entering the modern days. Now again, this particular web page is something that we studied for Henry Moseley's work. Okay, ultimately what was found out that there is a linear relationship between the root of frequency of emitted X-rays to a number Z. Okay, this was not atomic mass, this was the periodic property ka underlying factor, and what is that? That is known as the atomic number. It is equal to the number of protons. Okay, so this experiment again is not necessary for you to understand. Only thing that was happening is that the frequency of the emitted X-rays, now that you know spectrum and everything, it is super easy for you to understand. The root of frequency of the emitted radiations which were in the X-ray region is some constant into the atomic number minus some constant. So it is basically root of nu is proportional to your atomic number. Z is what? The number of protons. Okay, so Z is the number of protons. That was found later, but Henry Moseley found this relationship already. So they called it the atomic number. Later on, they understood that it is equal to the number of protons. So if they knew about protons already, they must have called it something different. Yeah, they should have called it proton number or number of protons or protonic number, but they called it the atomic number because they didn't know that protons exist. Yes, Amrit, this is the square root of frequency. Yo, cool. So this is the square root of frequency. Yes, in the definition as well. Yeah. This is the square root of frequency. Okay. So whenever it says root and doesn't mention what root, you assume that it is the square root. Okay. So this gave us the modern periodic law. Rohit, A and B are just constants. It is like root nu is equal to 3 times Z minus 4. 3 and 4 are just assumptions that I have taken. This is not the real law. Okay. So anyway, 3 and 4 are constants. Only the Z is changing, and so is the root of frequency. Okay. So these are just random constants that vary based on the different elements that you might have. Okay. So don't worry about it. All you need to know is this, that the root of frequency was proportional to the atomic number. So he deduced that atomic number is something that basically makes the whole basis of periodic properties of the elements. Okay? And that is where we build up the modern periodic table. So throwback time to Bohr-Bury scheme. Bohr-Bury scheme is basically the scheme of filling the electronic configurations. It comprises of Aufbau principle, Pauli's exclusion principle, and Hund's rule. Okay. This is the frequency of emitted X-rays. Okay, he did X-ray spectroscopy, something like that. Okay, or usme the X-rays that were emitted by different the X-rays that were emitted by different elements were proportional to a new number, which is the atomic number. Okay, to read more about his work, you can follow this particular link. Okay, which you can deal with later after this class. Since we have dealt with already, I'm not going to spend a lot of time on it. Okay, awesome. So Off-bow rule, Pauli's exclusion principle and Hund's rule. This is just off-bow principle, not off-bow's principle. Yeah. So just abhi revise kiya humne, so we won't go too much into it. Point is that this is what you get, right? So now the funda behind the periodic table is last electron defines the block in which your element lies. Okay, in the periodic table you have these particular 4 blocks, as you already know. Yeah, and you have a lamba sa block over here. Okay, so these blocks are known as my S block, P block, D block and F block. So if when you are writing the electronic configuration, okay, whenever you are writing the electronic configuration, the last electron, whichever subshell you fill the last electron in, that judges which group your element will be in the periodic table. Okay, so let's say your last electron goes into the S orbital. Okay, I believe the audio is back. What is the electronic configuration of sodium, people? Yes? This is the electronic configuration of sodium. The last electron is going in the... Hello, check. Hello, people. What's up? Yeah, it is back. So the last electron is going into the S orbital, and that is why sodium is present in the S block. Okay. Similarly, for chromium, we saw that the electronic configuration is what? People remember the last 3D4S? Copernicium कहाँ से आ गया मेरे दोस्त? Kushagam, don't. We are not talking about copernicium. I have just taken the order of orbitals over here in terms of their n plus l. So don't worry about it. People, chromium का configuration, please tell me quickly. Focus on the class, guys. I hope the audio is there. Hello, check. Okay, thank you so much, Ramya. Yes, awesome. I believe there is a slight delay in the audio. Okay, so 3D5, 4S1. Okay, so 4S1 में पहले भरा, then the last electron goes in 3D5, and that is why your chromium also lies in the D orbital. Similarly, for P orbital, you have fluorine, so on and so forth, and for F block, you have your build over all of these blocks of the periodic table. Okay, so for the number of elements in a particular period, okay, is filled in 1s2, still it is placed in the P block, okay, because its properties are those of the noble gases. Okay, hydrogen may it is 1s1, yes, it is kept here, okay, but its properties are similar to both alkali metals and also similar to halogens. Okay, also similar to the group of fluorine, chlorine, bromine, iodine and astatine. Okay, that is why both of these are considered to be exceptions. Okay, that is the only reason why both of these are considered to be exceptions. Okay, hydrogen ko you could have placed with these halogens as well, but you didn't. Helium ko its last electron goes in the S, but still you place it with the noble gases in the P block. Okay, so that is why you call them an exception. So this is your modern periodic table. Again, I have taken this image from ptable.com. It is a beautiful website that I've shown you already. Okay. So this is your S block. This is your P block. This is your D block. And this is your F block. Very simple. Now let us come to the S block. Okay. So in the S block, okay, we have just a little bit of time. Ramya will understand what that space means eventually. Okay. That is just a way to keep the atoms over there. So don't worry too much about it. Eventually everything will be clear. Okay. So let us just discuss about the S block first. Then we will sort of wrap up the session. Okay. But anyway, periodic properties is going to be a very fast chapter for us to deal with. Chalo. So the S block, this is your first group. This is your second group of the periodic table. Now in the first group, okay, the general configuration, I'll write it down for you and you will understand what it says. The general configurations for the first group are of the order of NS1. Does this statement make sense? If it doesn't make sense, please write a no. If this statement makes sense, then write a yes or yo. If it doesn't make sense, please tell me. I will explain it what it means. Yeah. So the general configuration ends with an NS1. Okay. So if you have the configuration of hydrogen, it is 1s1. If you have the configuration of lithium, it is 2s1. If you have sodium, then it is so on and so forth, 3s1. So on and so forth, 4s1 for potassium. And it will keep on going. Okay. So the general configuration for the first is NS1. Okay. And yes, N is technically equal to the number of the period that is in. Okay, so it's in the first period, so N is 1. This is the second period, so the N is 2, so on and so forth. Okay. Now, if you talk about the second group, can you tell me what is the general configuration of this one? Yup, exactly. NS2. Okay. The general configuration is NS2. There are 2 electrons in the S subshell for all of these particular cases. Okay, so for beryllium it will be 2s2, for magnesium it will be 3s2, for calcium it is 4s2, so on and so forth. Okay, so these are the general configurations of the S block. Okay, so the properties here are given as such. Okay, the first property is these are called, yes, Ramya, exactly. The helium should technically be in the second group, but it is exceptionally placed with the noble gases because its properties are totally those of the noble gases. It has no similarity with the properties of beryllium, magnesium, calcium, strontium, barium, radium, so on and so forth. So these are called alkali metals. Okay, the first group is known as alkali metals and the second group is known as alkaline earth metals because they are found in the earth's crust. Okay. Now these are reactive metals. Okay, always remember that these are reactive metals. What is a metal, people? Can you tell me the definition of a metal? How do you define a metal? What property is what makes metals? Okay, metals have basically the tendency to what? Yes, donate electrons, exactly. So metals have the tendency to donate electrons or lose electrons. Okay, so these are reactive metals, which means they tend to lose electrons. All right. Now they have low ionization enthalpies. People, for the next class, try to find out what does an ionization enthalpy mean. Shruti, that is just a. It was thought कि अब तक chemical bonding चालू हो जाएगा, but नहीं हुआ. That's the only thing. Okay, but don't worry about it. Okay, a lot of you know what ionization enthalpies are, so good. We'll anyway do the discussion on that on the next class. Okay, and the alkali metals give +1 oxidation state, which means they give ions like H positive, lithium positive, sodium positive, so on and so forth. They lose 1 electron, which means we call it to have +1 oxidation state. Alkaline earth metals, on the other hand, give us +2 oxidation states. Ions like beryllium 2 positive, magnesium 2 positive, calcium 2 positive, so on and so forth. ठीक है? And then the metallic character and reactivity increase down the group. Okay, in any group that you have in the periodic table, the metallic character will increase down the group. What is metallic character? Ability to lose the electron. Since you are going further from the nucleus, okay, you are going away from the nucleus, the attraction on the last electron because of the nucleus becomes very weak, because eventually you are going out in the outer shells. ठीक है? So उस वजह से the last electron is loosely bound in case of bigger atoms, and that is why their ionization enthalpy is lesser. It is easier for them to lose an electron, and that is why their metallic character increases. Okay, these are never found in pure state due to high reactivity. Okay, these are found in salts or compounds or molecules. Okay, so these are never found in pure state due to high reactivities. Okay, and these are predominantly ionic in nature. We'll see what that means in the next class. Okay, so people, today we have done a lot of things. Now the homework for you is to start reading the NCERT chapter of this. Yeah, Kushagam, yes, you are right. ठीक है, NCERT chapter इसका पढ़ना start कर दो. You know the drill. You already know the kind of frequency that we all work at. Yeah. So I hope that it was a session that was a bit different from the others. Yeah. We talked a lot about the atomic structure today. And सही है, a lot of people have read this chapter already as well. So वो भी बहुत बढ़िया बात है. So anyway, periodic properties will shift our gears. Okay. And we'll make things faster, okay, because periodic properties is perhaps the easiest chapter and yet the most scoring chapter. Okay, ठीक है? So people, that's it for today's class.